So using variations of parameters. So let's say they give a question like this. So you have 2 dy over dx minus 4 dy over dx. This should be a squared. Okay, suppose they give a question like this, right? And they ask you to use variations of parameters. The first thing we need to do is to find yc, right? Remember that our general solution should be in the form of y is equals to yc plus yp. And remember that yc is our complementary function and yp is our particular integral. So the first thing we need to find is yc. So that's what we're going to do now. So what we have to do is that we know from day one that dy is equals to dy over dx, right? So this is the substitution we're going to use to put in here. So here we have 2, and we realize that this is d squared y over dx squared. So that means that we're squaring this. So if we square both sides, we get d squared y. Then you have a minus 4 here. And what is dy by dx? It is dy. And you have your plus 2y. And this is going to be equals to e to the x over x, right? We realize that the y's are common between everything, so that's what we're going to do. We're going to factor out the y. So here we're going to have 2d minus 4d plus 2. And remember that we factor out the y, so it's going to have a y on the outside. And this is equals to e to the x over x. So there's something known as its auxiliary equation, right? So it's auxiliary equation. So with the auxiliary equation, it states that...
That's the d squared.
Oh yes, sorry, thanks for that. So you have d squared. So with the auxiliary equation, what we're going to do is that we're going to change the d to m, and then we're going to equate it to 0. So what you're going to have is 2m squared minus 4m plus 2, and this is now going to be equal to 0. So I can just erase this. So the next step we need to do is to try to find m. We realize that m will have 2 values because this is a quadratic equation, right? So what we could do is that if we factor this out, what we're going to have is, let me write it here. You're going to have m minus 1, m minus 1 is equals to 0, right? So what we're saying is that each bracket is going to equal to 0. So m minus 1 is equals to 0 for here. And for here now, we're going to have m minus 1 is also equals to 0. So over this side, we're going to say that m is equals to positive 1. And over this side, m is equals to positive 1 as well. So what we're saying is that we have two values for m. Let me just bracket it.
Yeah, you sure m is not equal to 2 instead of 1?
It is 2. I mean, sorry, it is 1. Because remember that if we divide out by let's say 2 here, right? It's the same thing as
Yeah,
saying m squared minus,
yeah, sir.
yeah.
Yeah, sorry about that. Sorry about that. I never saw the total from. Yeah, man, you're good.
Okay, great.
By the way, you are the maths president, right?
Yes.
For some of the integral king.
Yeah, the integral kings. All right. So we realize that we have two values for m, right? So what we need to do now is that we need to find YC. I hope you guys remember the formula. So what this is, these are real and repeating roots. So the formula for real and repeating roots is C1 plus C2 x, and it's raised to e to the mx, right? And we know that m is 1. So all we're doing is writing it in the formula. So YC is equals to, so this will be C1. What I want to do though is that I want to expand the e, right? So it'll be C1 multiplied by e to the x. Because remember that m is 1. And then here now we're going to have plus C2x and multiply it by e to the x. And then what we have now is that we actually find YC. So the last thing you need to do now is to actually find YP, right? So there's certain stuff you need to know, right? For YP, there's a formula. So YP is equals to V1 Y1 plus V2 Y2, right? So if you actually look on this now, if you actually compare, right? We're saying that V1 is C1 and Y1 is e to the x, right? And V2 now, so we have V2, Y2. So we're saying that V2 is C2 and Y2 is xe to the x. So what we're doing is that we're comparing. Let me just write it back over here. So we have YP is equals to V1 Y1 plus V2 Y2. So this is something you need to know. So what we're saying is that Y1, if you use comparison, Y1 is e to the x and Y2 is xe to the x, right? So that's what we're going to write. So what we're saying is that Y1 is equals to e to the x and Y2 is equals to x e to the x. Good? So what we need to find now is that we already have Y1 and we already have Y2, right? But what is missing? We need V1 and V2. So the formula for V1 now, so V1 is equals to minus the integral of Y2 f of x over a naught and this is divided by the wrong scan value, right? And we need to know that V2 is equals to the integral of y1 f of x over a naught, and it's divided by w. So these are the two formulas we need. So what we need now is that we have our y2 already, which is x e to the x. We have our f of x. F of x is what is on the right-hand side, which is e to the x over x, right? So we're saying that f of x is equals to e to the x over x. And a naught now is the first value that we have for the d squared. So that would be the 2, because it is the first value that we have here. So all we need now is w, which is the wrong scan value. So to find the wrong scan value, it is equals to y1, y2, and you have y1 prime, and you have y2 prime. The prime means that you're going to differentiate it, right? So what we're saying is that the wrong scan value is equals to y1 is e to the x, right? So we have e to the x, and y2 is x e to the x. So when we differentiate y1 now, when we differentiate e to the x, we get back e to the x still. And when we differentiate y2 now, we're going to use the product rule. So when we differentiate this, you hold the first, differentiate the second, and then you say plus, hold the second, which is e to the x, and then you differentiate the first, which is 1, and that's it. So w is equals to, so what we're going to do now is that we're just going to cross multiply, and you're going to minus the values, right? So it's going to be e to the x multiplied by this, e to the x multiplied by e to the x, e to the x multiplied by e to the x times x plus e to the x, and it's going to minus what is here now, which is e to the x multiplied by x e to the x. So what we need to do now is that we just need to simplify. So w is equals to, so if we expand this out, right, this is going to be x e to the 2x plus e to the 2x, and you're going to minus it from x e to the 2x. Because remember that this is e to the x and this is e to the x, so it gives you e to the 2x, right? So what we realize now is that this cancel and this cancels, right? So therefore, we're left with w is equals to e to the 2x. So this is your wrong scan value. So to double check now, remember that this is our answer for yp, v1 y1 plus v2 y2, right? So remember that y1 is e to the x and y2 is x e to the x. So now all we need now is v1 and v2. The formula for v1 is this, it is fixed, so you only need to know it. And v2 is the formula for this. So we have our f of x, which is this. We have our a naught, which is 2. Our wrong scan value now, which is e to the 2x. So all we need to do now is just to sub in everything and then just integrate it. So that's what we're going to do now. So we're going to start with V1. So we say that V1 is equals to minus the integral y2. Y2 is xe to the x. So this is just xe to the x. And then we have f of x over a naught. So we're saying that is e to the x over x divided by 2. So it's we multiply by e to the x over x divided by 2. I'm just write this much better. Bigger integral sign. And then we're going to divide it by the Wronskian value. The Wronskian value is e to the 2x because Wronskian value is here. So it's e to the 2x. And we're going to differentiate in respect to dx, right? So all we need to do now is just to simplify. So V1 now is equals to, what can we simplify now? So if we multiply out throughout, right? We can say this is x e to the x multiplied by this that is at the top, right? So we're saying that it's the integral, and you have the negative sign here, of x e. So it's x e to the x times e to the x, which is e to the 2x. And it's being divided by x. And then over 2. Well, that shouldn't be a long 2. So you're dividing it by 2. And then all of it now is divided by e to the 2x. And you have your dx. So all we're doing is just just need to integrate. Once you can integrate, that means that you'll be fine. So V1 now, let me just change the color. V1 is equal to minus integral. All right, let's see what we can cancel, right? So at the top, it is x e to the 2x divided by x. But remember that it's also divided by 2. So when you divide by 2, you're multiplying by a half. So this is going to be 2x, right? And then now you're dividing by e to the 2x. So here now it's just going to be e to the 2x here. I hope you guys see that. So what now we need to do is that we need to cancel again. So this e to the 2x cancel and this cancel. This x cancels and this x cancels. So what we're left with now is this. So we're saying that V1 is equals to minus integral of a half respect to dx. So V1 now is equals to minus a half x. And this is your V1. Sometimes the integration can be a bit lengthy. But again, once you know how to integrate, then you'll be fine. Next thing we need to do now is that we need to find V2. So now V2 now is equals to the integral. V2 is here, y1. Y1 is e to the x. So you have e to the x, and it's been multiplied by f of x over a naught. F of x is e to the x over x divided by 2 over the Wronskian value. And this is over the Wronskian value, which is what we got was e to the 2x. And then we don't just going to differentiate this. So we have v2 is equals to the integral. We're going to multiply this out. So it's e to the x times e to the x, which is e to the 2x. And seeing that it's divided by x and then divided by 2, it is going to be over 2x. And then this now is divided by everything. So you're just going to have e to the 2x still in the denominator. And then we're just going to differentiate this. So if you don't know how to hello?
Yes, sir. How you get the Wronskian value?
The Wronskian value from here. This is a formula. y1, y2, y1 prime, y2 prime. So
Okay,
we know y1, which is e to the x, and y2 x e to the x. And then we just differentiate it. So we differentiate this, put it here. We differentiate this, put it here. And then you cross multiply and minus them, which is what we do here. I end up with e to the 2x.
yes, sir. All right. So how you get that A naught value?
A naught?
Yes, sir.
Oh, A naught is always the value that is at the front, which is 2.
All right. Thank you, sir.
Yeah. So this will cancel and this cancel. So you're saying that v2 is equals to the integral of 1 over 2x with respect to dx. So we're just going to come up here. So v2 now is going to be equals to, we're going to take out the half, right? So it's going to be a half integral of 1 over x dx. So v2 is equals to a half. And the integral of 1 over x is ln x. So this is ln x. So we basically finish. So we can say now our yp is equals to v1. What we got for v1? V1 was a half, negative a half x. And then we say y1. Y1 we got was, what did we say for y1? Y1 is e to the x. And then we say plus v1. V1 now is, sorry, v2. V2 is a half ln x. And then you add it with y2. Because all we're doing is using this formula, you know. And you multiply it with y2. And y2 was x e to the x. And remember again, our final answer is in the form of y is equals to yc plus yp, right? So therefore, we're saying that y is equals to yc now we got earlier was, this is what we got earlier for yc, which is c1 e to the x plus c2 x e to the x. C1 e to the x plus c2 x e to the x and then we add it with yp, which is all of this. So this is going to be minus a half x and it's multiplied by e to the x plus a half ln x, and it's been multiplied by x e to the x. And that is actually your final answer using the variation of parameters. Is there any question for this?
No, pretty clear.
All right, great. So that's all it is. So just to refresh, you find YC, right? We know to find YC. You put it in the operator, and then you use this formula. YP is that you just use this formula, V1, Y1 plus V2, Y2. We gave it the formula for V1 and for V2, which was these. And then all you do is just substitute in everything and then just integrate. And you just easily get your answer. Anything else you guys want me to do? Which other question? Another variation of parameters or any question at all? Could be a power series, a homogeneous, variable separable. No particular question you guys would like me to help you with?
We can do one where we actually solve the YC.
You mean YP?
Wait, no. No, YC is one with C1 and C2 in it, right?
Yeah.
Yeah, the one of those where we have to sub in back. I kind of give you values. You know what I'm talking about.
That would still be a variable separable or a homogeneous differential equation you're talking about?
Any one, as long as it's the ones where them normally give us like dy dx equal to something.
All right.
When x equal to something else.
I have a question after. It's a variable variation parameter. Sorry.
All right, sure. So let me just show you guys just something quickly, right? So you know that a question would be in the form of d squared y over dx squared. And you're just going to have values, right? You're going to have constants here. So let's say a naught. And you're going to have plus a1 of dy over dx. And you're going to have another constant, let's say a2 of y. And this is equals to, let's say 0, right? The first thing we need to do is to make this, we need to make dy over dx dy. And you know what, when you square this, it's going to just be a naught d squared y plus a1 dy plus a2y. And this will equals to 0. So all we're doing is that first thing you should do is that you're saying that dy over dx is equals to dy, right? And if we square both sides, well, I'm gonna say square. Square isn't the best word to use, but I'm gonna use square. And if we square both sides, this is going to be d squared y. So that's how we use a substitution. So we substitute this and we substitute this, and you end up with this, right? And then next thing you want to do is that you need to take out the y. So when you take out the y now, you're going to have a naught d squared plus a1 d plus a2, and then you're going to have a y on the outside, and this is going to equal to 0. Next thing you should do is to make whatever inside the bracket equals to 0. It doesn't matter if this is e to the x or cos y or whatever, all of this should be equals to 0, right? So you're going to equate this to 0, and then you're going to say, you're going to change the d's to m. And then there's 3 solutions you can get, right? The 3 solution is that, suppose you have for m at the end, let's say you get 1 and 1. These values are repeating. So your answer would be yc is equals to c1 plus c2x e to the mx, right? But suppose you get a value that is not repeating. Let's say you get a value like 2 and 3. These aren't repeating like we have 1 and 1. The formula for yc now will be equals to e to the x, well, c1 e to the x plus c2 e to the x, e to the mx, sorry. So put an m here. Let me just rewrite it, sorry. So yeah, so when you don't have a repeating root, it's going to be yc is equals to c1 e to the mx, and you're going to have plus c2 e to the mx, right? However, suppose you do it now and then you get a complex number, right? So let's say you get m is equals to 2 plus or minus 3i, right? The formula for this now for yc, so anytime you have a complex number, you use this formula. So it's e to the alpha x, and it's being multiplied by c1 cos beta x plus c2 sine beta x. So these are only the 3 formulas you need to know. When they're repeating roots, you use this formula to find yc. When they're separate roots, like they're different, you use this formula. And then when you have a complex number, you use this formula. So the alpha would be 2 and the beta would be 3. And you just sub in everything and then you just easily get an answer. We have less than 1 minute. So what you guys should do is that just use the same login information. When this has expired, I'm just going to continue the question. Like the same, somebody want me to solve a variable separable or something like that. Next question. Someone mentioned that they wanted to do a variation of parameter question.
No.
Any question, guys? Any question you want me to solve or go through? Are you guys hearing me, by the way? Just raise your hand or something, so I just know that you guys are actually hearing me.
Yes, sir, we're hearing you.
All right, great.
Sir, I don't know if this is type of question this is, but I have a question.
All right.
Dy over dx
Wait, sorry, I
is
didn't hear that.
dy over dx
Mm-hmm.
is equal to
Yeah.
bracket 2x plus 3y plus 5 close bracket square.
2x plus 3y plus 5.
Yes, sir.
And it's all squared, right?
Yes, sir.
All right. So anytime you have a question like this or in this form, you're supposed to use a substitution. This is actually a variable separable, I believe. So the first thing you should do is like when you have like a function and it's all of it is being squared, you use a substitution. So we could just say let z is equal to whatever this is, right?
Yes, sir.
So we're just going to say z is equals to 2x plus 3y plus 5. So if we say z is equals to this, what we're actually saying is that dy over dx is equals to z squared. Seeing that we say z is equals to this. So all we do now is that we differentiate this part here. So what we're saying is that dz, and we're going to differentiate respect to x. dz over dx is equals to, when we differentiate 2x, we get 2. And then you're going to say plus, when we differentiate this now, this is going to be 3y dy over dx. Wait 1 second, guys. All right, so we're just going to continue. So my mistake, this is supposed to be a 3. Just 3dy. So let's erase this. So remember, when we differentiate this, we get a 2. When we differentiate this, we're going to get a 3. And we have dy over dx because we differentiate in respect to x, right? And then when we differentiate a constant is equals to 0. So what we need to do now is that we need to transpose for dx after. So what we're saying is that 3 dy over dx is equal to, we're going to bring the 2 over this side. So if we bring this over this side, it's going to be dz over dx, and it's minus 2 because over this side it was a positive. And now we need to get rid of the 3. So we're saying is that dy over dx is equals to dz over x dx minus 2. And we're going to, see that it's being multiplied by dy over dx, we need to divide, right? So this would just be all over 3. So we realize that this has a dy over dx and this has a dy over dx. So all we need to do is that we just need to equate both of these. So it's equating this here and we want to equate this here. So what we're saying is that z squared is equals to all of this, which is dz over dx minus 2 all over 3. So if we put the 3 over this side, so we just cross multiplying, this will be 3 z squared is equals to dz over dx minus 2, right? Because this is a variable separate, if you guys didn't know. So then we need to do now is that we can bring the 2 over to this side, right? So this will be 3 z squared plus 2 is equals to dz over dx. And we realize that z's are over this side, so this z needs to come over this side. So we cross multiply again. So you can put this over 1. So you cross multiply. So we're saying that dz is equals to 3z squared plus 1 and you have your dx. This needs to come over to this side because remember you need all the z's on one side and all the x's on one side. So this would be 1 over 3z squared plus 1 is then you have your dz, and this is equals to 1 dx.
So should that be 3z squared plus 2?
Oh yes, sorry, thank you for that. It's supposed to be a 2. So I hope you guys understand to this point. So remember that when we're doing variable separable, the last thing you should do is that you just need to integrate. So we integrate in both sides, right? So when we integrate this now, this looks like, does anyone know how to integrate this by any chance? Nobody? All right, how I would imagine this is that this looks like a tan function, right? I remember the formula for tan in math 1. It says that when you have 1 over 1, no, I don't want to use that formula. Let me use this one. When you have the integral of k over a squared plus x squared respect to dx, it gives you 1 over a tan inverse of b over a x. This would be over ab. And then you have your plus c. Right, so this is the formula we're going to have. So if you look at this now, you need this to be squared and you need this to be squared. So we're saying that this is our a and this is our b. So if you actually integrate it, it will be 1 over square root of 2 and this would be 1 over square root of 2 tan inverse of square root of 3 over square root of 2. And this is equals to, when we integrate x, when we integrate 1, we just get x. Right? But remember that we say z is what? Z is here, 2x plus 3y plus 5.
Sir, up the top you have 1 over AB, but down here you only have 1 over square root of 2.
Yeah, because remember that there's no. All right, if you look at this, if you look at this, right? Remember that we need this to
Yes,
be
sir.
squared and we need this to be squared, right?
Yes, sir.
So what we're saying is that it is the same thing as the integral of 1 over square root of 2 squared. Because square root of 2 squared is the same thing as 2, right?
Yes, sir.
And then we say plus, this needs to be squared as well. So this is the square root of 3 z all squared. So therefore, we could treat all of this as seeing x.
Okay.
Clear?
I see. Yes, sir. I see it now.
Yeah. And then we said that z is equals to what? Z is equals to 2x plus 3y plus 5. And then over 2 and equals to x. And that's your answer. Any question on this? Is there another question you'd like me to solve? Everybody clear on that?
Yes, sir. Yes,
Yeah,
sir.
give me,
Is there another question?
yeah, give me 1 minute there.
All right.
Okay. 4d square y over dt square minus 4 dy over dx plus 5y equals 17 cos x.
All right.
That's
That's it?
y equal to, no, given that y equal to dy over dx equal minus 7 over 7.
I didn't hear that.
Y equal to
Y equals to
dy is equal minus half.
You said dy over dx equals minus a half. That's it?
When x equals 0.
All right. So we can just go and solve this then, right? So first thing we need to do is that we just need to find the general solution for y. Y is equals to what, right? So question, what exactly did the question state? Hello?
Yeah, coming.
All right.
We got it in a tutorial. It was tutorial 2, but I don't have the paper. I just saw it in my book.
Oh, I would love to actually have the question, like what exactly is supposed to solve. But I'm assuming that you're supposed to just find y and then just probably make necessary substitution. All right. So the first thing we need to do is that we need to put this, we need to find yc. So we're making substitution for d squared and for d, right? dy. So we have 4 d squared y minus 4 dy plus 5y, and then you have your 17 cos x. Remember that the next step we need to do is that we need to take out the y's. So you're saying that is 4 d squared minus 4d plus 5, and you have your y on the outside, and this is equals to 17 cos x, right? Remember that there's something called your auxiliary equation. So what you need to do now is that you change the d's to m and then you equate it to 0. So you have 4m squared minus 4m plus 5, and this is equals to 0. So what we need to do next is that we need to try to find m. So can this factorize? So 4 times 5 is 20. And we need two numbers that when you add it, you get minus 4.
No, that can't factorize. You have to use a formula.
We have to use the formula? All right. So that's a long one now.
Well, I got half plus I minus I. I don't know if you can get it.
So m is equal to a half plus or minus I.
Yeah.
All right. So that means what we're saying now is that our yc is equals to, remember the formula which says that's e to the alpha x, and then you have c1 cos x, and you have plus c2 sine beta x. And beta should be here. This should be beta x. So all we do is that we substitute the formula into this. So our alpha is a half and our beta is 1 because there's an imaginary 1 here. So now we're saying that YC is equals to E to the half X, open bracket, C1 cos beta is 1, right? So it's just going to be 1x, which is just x. And this is plus C2 sine x. And this is your YC. Remember, the next thing we need to do now is to find your YP, right? So your YP now will be equals to 1 over, so it will be 1 over this, 1 over 4d squared minus 4d plus 5. So it's 4d squared minus 4d plus 5. I remember that it's going to be multiplied by 17 cos x.
Is it 4? It can't be 4. How many students? Oh, you add up all these together? How many students I achieve?
So that is the formula on how you actually find YP, right? So what we need to do now is that we need to make the necessary substitutions. We need to say that d squared is equals to whatever is here. We realize that there's a 1 because it's same as cos 1x, right? So in that saying that d squared is equals to negative a squared. This is a formula you need to know when you're using any trig function. So we're saying that d squared is equals to negative 1 squared. And negative 1 squared is the same thing as negative 1, right? So all you do is that you're substituting d squared equals negative 1. So we have YP is equals to 1 over 4. Remember that d squared is negative 1. So you have minus 1. I have minus 4d. And you have your plus 5, right? And you're going to have the 17 cos x. So we're just simplifying. So it's going to be 1 over. So this is going to be minus 4. But minus 4 plus 5 is 1. So it's just going to be 1 minus your 4d. And it's being multiplied again by 17 cos x. Next thing you need to do is that there's something called your composition. So all you do is that you change, you multiply it by 1 plus 4d. So all you do is that you change the sign, what is inside the middle, right? So you multiply the numerator by 1 plus 4d, and you multiply the denominator by 1 plus 4d as well, right? So we can just simplify. So remember, all the time, after you reach this stage, you're just going to change the sign and you multiply the top and the bottom by it, right? So we're saying that this multiplied by 1 is the same thing as 17 cos x. And then you have your plus. And you're going to have 4d. And you have your 17 cos x. And then you have over, let me put a bracket here. So you're multiplying 1 minus 4d by 1 plus 4d. When you multiply this out, you're going to be 1 minus 16d squared. I remember that we have this, right? Again, remember what d squared is. D squared is minus 1. So that's all you're going to do. So you're going to have 17 cos x plus 4. Now this d means that you're going to differentiate what is inside here, right? So when you differentiate 17 cos x, you're supposed to get, when you differentiate cos x, you get minus. So it's going to be minus 17 sin x. And it's going to be over 1 minus 16, and it's being multiplied by d squared is what? Minus 1. So your yp is equals to 17 cos x minus, all right, 17 times 4 is 8, 2, 6. I have your sin x. And all of this is, so this becomes a positive 16, right? And plus 1, so it becomes 17. And this is your answer for yp. So remember that our final solution is y is equals to yc plus yp. So our yc that we had earlier was this, e to the half x c1 cos x plus c2 sin x. And then you're going to add it with yp. Yp we got was all of this, which is 17 cos x minus 68 sin x and it's divided by 17. Is it 17? Yes. And this is your answer for y.
So where the conditions came in, you would have to do it. You would have to do it now.
That's the thing. Let me see. That's the thing. I actually wanted the question itself. What is it finding? Is it finding the constants or what? Because it's a bit unclear. So what I'm assuming is that all you do is that you sub in the values. I think it might be a proving question. So when you sub in the values for x equals 0, for here, you should get 2.
Oh, okay.
Is there any more question, or you want me to clear up this more, like explain it more in details, or are you guys okay?
No man, it's alright.
All right. I'm surprised that you guys not giving me any power series question. Is
But
it
we
not
don't have
coming on
any
the
to give.
exam? Hello?
We don't have any question to give. You can give us, you can just search on.
All right, sure. All right, let me just go through a little trick with you guys. Like some things you can easily know, right, for the exam. First of all, for variable separable, how you know if it's a variable separable is if you can have all the x's on one side and all the y's on one side, right? How you know if it's a homogeneous, let's say you have a question that says dx over dy is equals to xy plus y squared over 2x squared, right? How you can know if this is a homogeneous is if you add the powers. So let me just use red. So this has a power of 1, x has a power of 1, and y has a power of 1. When you add both of them, it gives you 2, right? You realize that y has a power of 2 as well. And x has a power of 2. So you know that it's homogeneous. So let's say you have 2x cubed plus 4 plus x y squared dx is equals to 4 y cubed dy. How you know if it's homogeneous is that you add the powers. So this one has a power of 3. So x has a power of 1, and 1 plus 2 is 3. And this has a power of 3. So that's how you know if it's homogeneous. That's just a trick because they gave you a formula to prove if it's homogeneous. I think it's something like if you have f of xy, it should give you lambda of f of xy, right? But this is just a shortcut. This one is just a shortcut. If the powers, when you add them up, is equals to the same throughout, that's how it is a homogeneous.
How do you know it's a variable separable? Again, yeah, it says something.
Yeah, variable separable is if you can put all the x's on one side and all the y's on one side. So for example, suppose you had a question like 2x over y is equals to dy over dx. Is it possible for us to put all the x's on one side and on all the y's? If we cross multiply, we're going to have 2x dx is equals to, I multiply the y and the dy, so it becomes y dy. You realize that all the x's are on one side and all the y's on the other side, so therefore it's variable separable. So only thing you have left to do is just to integrate. So that's how you know if it's variable separable. If it's which other ones are there? If it's a linear differential equation, you know that it's in the form of dy over dx plus p of x y is equals to q of x. So an example of a first order linear differential equation is if you have, let's say, 2 dy over dx plus let me use 2xy is equals to e to the x. Let me not use e to the x. Let me use a constant. Is equals to 4. you realize that the P of X is 2x and your Q of X is 4. So that's how you know if it's a linear differential equation. If you know if it's a Bernoulli now, the only difference is that you have a y to the n. Right? That is how you know if it's a Bernoulli. So if you have y to the cube, this now is a Bernoulli equation. And the last one you have, if it's an exact, if it's an exact differential equation. If it's an exact differential equation, you know that del, what is it? Del, you have your x. You have to use partial derivative and they have to be equal to each other. I don't quite remember. I think you have your del m over, and this is del n. One of this is supposed to be an x or a y, and it's supposed to be an x or a y, but I don't remember. But once these are
delta
equal,
m over y and delta n over x.
all right, good. So this is how you know if it's a exact differential equation. If del m over del y is equal to del n over del x. So those are just like some simple rules you need to know how to solve them, right? So that's just like a summation of, or a summary of differential equations, first order differential equations. The only problem I see you guys having for second order is the YP. YC is easy because you just need to put it in its D operator form and then you change it to its auxiliary equation and solve for M. And you know that you get 3 values for, or 3 answers for M. So if it's a real, if it's real or distinct, if it's real and the same, and if it's a complex form. The only problem I see is the YP. There is different tricks there for finding YP, right? So that's just basically it for your differential equations. So all you do is just practice and then you get better.